Welcome to Study Loop.
Okay, we are interested in phenol, and we are interested in phenetole. And the question is, what is the IR spectrum for each of these? Well, what IR spectrums are generated from are the stretches, right, that the various bonds make. So if you can identify the types of bonds you have in your atom, in your molecule, then you can predict what the IR spectrum will look like, right? And so there are some key bonds in each of these uh, reagents or molecules, which will give us signature peaks in our IR spectrum. So let's start with phenol. Note that we have carbon-carbon double bonds, right? There are hydrogens all around this molecule. And so we have sp2 carbons bound to hydrogen, right? That's clearly uh, present. We do have sp2 carbons bound to oxygen, and then we have oxygen bound to hydrogen. Now, as it turns out, some of these have key locations in the IR spectrum. For example, OH in the IR spectrum shows up from 3200 to 3400 in a broad stretch. Okay. sp2 carbon oxygen bonds show up in the fingerprint region, which means they don't show up in the diagnostic region of an IR spectra, so we can't predict where these will show up in any meaningful way, so we just don't really count them as being a functional group that we're looking for in the spectrum. sp2 carbon hydrogen bonds will always show up in the 3000 centimeter region. Centimeter inverse region, or wave number, and they are a sharp peak. Okay, and then we've got carbon-carbon double bonds. These also show up in the fingerprint region, right? So there's no diagnostic stretch for carbon-carbon double bonds. And so then let's look at phenetole, right? Uh, We've got basically all the same exact bonds. We've got CC double bonds. We've got carbon sp2 to hydrogen. We've got carbon sp2 to oxygen, but we no longer have OH, right? We only have oxygen to carbon and oxygen to sp3 carbon. Okay, and now we have carbon-carbon, sp3 carbon to sp3 carbon, and we have sp3 carbon to hydrogen, right? There's hydrogens on these sp3 carbons. So which of these have diagnostic stretches? Well, we know that the carbon-carbon does not. We know that the sp2 carbon oxygen does not. And as it turns out, sp3 oxygen, sp3 carbon oxygen bonds are also in the fingerprint region. So are sp3 carbon, sp3 carbon, which leaves us with two diagnostic stretches. That's the 3000 sharp stretches for sp2 carbon hydrogen, and sp3 carbon hydrogens also have a sharp stretch, but this is going to be below 3000 and sharp. Right, so then what our IR spectra would look like for each of these would be we would have our alcohol from 3200 to 3400. And then we would have our sharp, sorry, I forgot to say these are greater than 3000, not exactly 3000. They're slightly beyond 3000. And then we would have our sp2 hydrogen, sp2 carbon hydrogen as a sharp peak. Just beyond 3000. So I'll say this is the 3000 dividing line. And this is our 3400. And this is our 3200. All right, so those would be the peaks we expect. And then in the fingerprint region, you can't predict anything. And so let's do the same for phenetole. It's going to be pretty similar, but we will not have an OH stretch. And on either side of our 3000 dividing line, we'll have a sharp stretch. Right, one from sp3 carbon hydrogen bonds and one from sp2 carbon hydrogen bonds. And then no other stretches until we get into the fingerprint region, like so.